I will show you the same process using the Pascal's triangle on this next example, which is 2a minus b to the fifth power. So I'm going to start out with building my Pascal's triangle. A plus b to the 0 power is 1. Then the following row is 1, 1, which is a plus b to the first, a plus b to the second, a plus b to the third power, a plus b to the fourth power, and a plus b to the fifth power will have these coefficients. So I'm going to start out with writing those coefficients in a row. So I have 1, 5, 10, 10, 5, and 1. And I'm going to start building the next part of it, which will be 2 times a to the fifth power plus 5 times 2 times a to the fourth power times negative b plus 10 times 2 times a to the third power times negative b to the second power plus 10 times 2 times a to the second power times negative b to the third power plus 5 times 2a and negative b to the fourth power. And for the last term, I have negative b to the fifth power. So now I'm going to start simplifying. So the first one is 2 to the fifth, which is 32a to the fifth power. The second term will give me 5 times 2 to the fourth, which is 16a to the fourth times negative b. The next term is going to give me 10 times 2 to the third, which is 8a to the third, and times b to the second. Negative b squared is b to the second, plus 10 times 4a squared times negative b to the third, plus 5 times 2a times b to the fourth, and for the last term I get minus b to the fifth power. So if I simplify even further, I get 32a to the fifth minus 80 a to the fourth power times b plus 80 a to the third power times b to the second minus 40 a to the second power times b to the third power plus 10 a times b to the fourth power minus b to the fifth power. And this is my final answer, which again I could have gotten using the binomial theorem or the Pascal's triangle. In this next example, we need to find the fifth term of the binomial expansion of x plus y to the sixth power. So I'm going to start out writing that the coefficient will be the combination of nr, and the first term, which is x, is going to be to the n minus r times y to the r. So now I need to identify what n and r will be. N will equal to 6, and it comes from the sixth power. And r will equal to, we are finding the fifth term, so it's going to be 5 minus 1 or 4. So let's go ahead and find the expression. So it's the combination of 6 choose 4 times x to the n minus r, which is 6 minus 4, times y to the r, which is 4. So now I'm going to evaluate. So the combination of 6 choose 4 is 6 factorial over 6 minus 4 factorial times 4 factorial, which will be 6 factorial over 2 factorial times 4 factorial, which is 6 over 6 times 5 times 4 times 3 times 2 times 1 over 1 times 2 times 4 times 3 times 2 times 1. So if I simplify by 4 factorial and I also simplify by 2, my answer is going to be 15. So 15 times x to the second power times y to the fourth power is going to be the fifth term of this binomial expansion. What I also would like you to realize that in the binomial expansion, you always will have one more term than the power you are raising the binomial to. So for example, if you are raising the binomial to the sixth power, you're going to have 7 terms. I copied and pasted again a binomial expansion to the fifth power for you, just so you can see that when you have a binomial expansion to the fifth power, we start out with r equals 0 in the first term and r equals 1 in the second term. So in the fifth term, my r will equal to 4, and that's the reason why we had to calculate in the fifth term 1 less 5 minus 1 equals 4. If we have a set of n objects and we take r at the time, the number of subsets containing r members is n choose r, or n choose 0 plus n choose 1 plus n choose 2 plus n choose n, or these are the sum of the combinations. And if we expand 1 plus 1 to the nth power, it will be again the combination of n choose 0 plus n choose 1 all the way to n choose n. The total number of subsets of a set which has n elements is 2 to the nth power. So if we look at the example, how many subsets can be made from a set that contains 8 elements? I would say 2 to the 8th power, which is 256. And in the next example, or in the last example for this lesson, if there are 10 toppings for a pizza, how many different kinds of pizza can be made? So in this case, we are going to say 2 to the 10th power, which is 1024.